Hello guys, welcome again to another video. So in that video, we're gonna, discuss another type of operations rather than the arithmetic operation. We have also what's called the logical operations, which basically make or logic operation between variables like and, or, such kind of operations. Okay. So the first, operations that we can do is the ANDing operation, bitwise ANDing operation. And I mean by bitwise here is that we make the ANDing between each two bits or each corresponding bits, in two variables. So the general form of this operation is AND, destination and a source. Okay, so it will do the logical, ANDing between the operands, and the result will be stored in the destination. So the destination will change after this operation. The destination operand can be a register or a memory. The source operand, however, can be register, memory, and also immediate values. This operation has a very nice, characteristic. It automatically changes CF to 0, the carry flag. CF here is the carry flag. So the flag register will change, okay, and automatically CF, will be 0 all the time after ANDing. Of course, other flags like the parity, the 0 flag, the sign flag will be set based on the operation. And to refresh your memory about the ANDing, if we have two bits like this, x and y, x and y have the same, such output like 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So the output will be 1 only if both inputs x and y are 1s. What kind of applications, we can use, the AND operation? One operation is, or one application is masking. Sometimes you need just to concentrate on certain, part of a variable, like for example, a certain bit or a certain 2 bits, whatever, okay, and neglect the other. So we said that we will mask some part and leave the other part. So for example, here we are interested in the first 4 bits of this variable or this value. So we can mask the last, or the most significant 4 bits. So for this, we can AND that variable with 4 zeros and 4 ones. So let's do it one by one. 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. So look, this doesn't change. So the first 4 bits doesn't change because we are ANDing them with 4 ones. But the most significant 4 bits will be all zeros. Why? Because we are ANDing with 4 zeros. So 1 and 0 is 0, 1 and 0 is 0, 0 and 0 is 0, 1 and 0 is also 0. So basically, based on that, we could mask here, the most significant 4 bits. And, in that example here, AH has in the beginning such value. After, this operation, AH will be 4 zeros, 0, 1, 0, 1, 0. Okay. Another application is, it can test for 0 operand. If you have a register and you want to check if this register has a 0 or not, you can AND it with itself. So if the H is 0, for example, something like this, when you AND it with itself, then the output, of course, will be 0. And in that case, you can jump, you can make, for example, jump 0, jump F0, and in that case, it will jump. Okay. The second operation or logic operation is OR. Here is, how the OR operation is performed with 2 bits. 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. So the only case in which the output is 0 when both are zeros. It's opposite to the AND. So the AND, you know, it's always 0 except in one case it's 1 when both are ones. Here it's all ones, all the time ones, except in one case when both are zeros. Again here, the destination and source operands are ordered together and the result will be placed in the destination. That's why it's called destination. Okay. The destination operand can be a register or a memory. However, the source operand can be register, memory, or immediate value. Again, the flags will be changed or can be changed, you know, based on the result of the OR operation. And again, the carry flag will be 0 all the time. Whenever you have AND or OR now, you know, the carry flag will be reset to 0. And again, the sign flag, the, you know, the 0 flag, the parity flag will be set according to the output. One application for the OR operation is to set some certain bits to ones. And also can be used to test for a 0 operand. So you can use it in that way or that way. Okay. So let's take in one example for the first one here. So for example, if you have, you know, a variable like this, and you wanna, for example, set the first bit, what you can do is basically to end it with that value here. Just end it with FF. I'm sorry, or it was you know 0 0 0 0 0 0 0 1, or it was 1. Okay, so which, and the one here because we want the first bit. So in that case, 0 or 1 will be 1, and the rest will be the same because, you know, when you OR something with zeros, it will be the same. If you want, for example, to, you know, to set the second bit, let's do it. So basically, you're gonna OR with 2. And again, you know, when you OR something with 0, it will be the same. But here's the second bit here, you know, since you OR with 1, it will be 1. I'm sorry, this is 0 here. So 0, 0. Yeah. We said also it can be used to test for a 0, just like the AND. In that case, we can say OR, BL, and 0. We said with the AND, we said AND BL and BL. You AND it with itself. If it's 0, then, you know, the ending will be, you know, will give you 0. Here to test for, you know, for a 0, you AND it with, you OR it, I'm sorry, with 0. So for example, here in that case, you know, let's take the same case. That variable is not 0. So when you OR it with 0, it will give you the same value again. So that's not 0. But if it was 0, 0 or 0 will be 0. And in that case, you know, the 0 flag will be set. Let's take a bigger example. Like, for example, here we're gonna, you know, move that value 0504 to AX. Then we're gonna, you know, OR that value here with that value. So here is the 0504. This is 0504, and this is the D A68. This is D. This is 6. This is, I'm sorry, A. This is 6, and this is 8. And again, bit by bit, because it's again and or whatever we're gonna take, it's bitwise operation. 0 or 0 is 0, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 0 or 0 is 0, 0 or 1 is 1, 0 or 1 is 1, 0 or 0 is 0, and so on. Okay, now let's check the values for the flags. Okay, again, without looking at the output, the carry flag should be 0 all the time. The carry flag, since it's a logical operation, the carry flag will be 0. The sign flag we look at, the last bit. The sign flag will be 1 here. The zero flag we look at the operation overall. So the operation overall gives you a non-zero value. So the zero flag will be 0. That's not a 0. For the parity, remember, for the parity, we always look at the least significant 8 bits, not the whole result. So in that case here, these are, this is the least significant 8 bits, and we have here 4 ones. That's an even number of ones. So the parity flag will be, okay, guys? Good. XOR, the XOR operation. Again, the general form is XOR destination and the source. The exclusive OR operand, it's exclusive OR, between the destination and the source, and the result will be stored in the destination, just like the AND and the OR. And this is a very simple rule for the XOR. Okay, it has a general rule and a simple. Since we are doing the bitwise operation, we're gonna need the simple rule. The simple rule is very simple. It says if the 2 bits are similar, then the output is 0. If the 2 bits are different, the output is 1. So here, for example, 0 XOR 0 will be 0 because they are similar. 1 XOR 1 is 0 also because they are similar. But 0 XOR 1 or 1 XOR 0, both will be 1s because they are different. But the general rule, just for your information, you count the number of 1s. If the number of 1s is even, then this will be 0. If the number of 1s is odd, this will be 1. And you can still apply it here. So 0 and 0, here's the number of 1s in these 2 operands, is even. So the output is 0. Here is the number of 1s is even because we have 2 1s here. So the output is 0. But here in the in the middle here, 0 XOR 1 or 1 XOR 0 both have just 1 1. So it's an odd number of 1s, so the output is 1. And the flags will be raised similar to the AND and OR instructions. Okay. The applications for the OR, this can be used to see if 2 registers, to compare basically, if 2 registers have the same value. Because if you XOR, 2 similar values together, as we said, the output will be 0. So here, for example, if BX equal to CX, that means XOR BX and CX will result in 0 or zeros. Okay, and this 0 will be stored in BX. And in that case, the 0 flag will be 1. But if they are different, then you will have at least, a single bit, which have a 1 in the out. And that in that case, the 0 flag will be 0. We can also use the XOR to what's called the toggling, basically inverting. So if you have certain bit and this bit can be 0 or 1, toggling means to convert 0 to 1 or 1 to 0. That's meant by toggle. It's just like an inverter. So whatever the input value, it will be the opposite in the output. If it's 0, it will be 1. If it's 1, it will be 0. So for example here, if you want to toggle bit number 2 is the 3rd bit, because you always start counting from 0. So if we want to toggle here, the 3rd bit of AL, okay, we AND it with 4. I'm sorry, we XOR it with 4. Okay. So here is, the bit that will be toggled, the 3rd bit or bit number 2. Okay, and let's take an example. Let's say, for example, that AL has this value. What we want to do here is to toggle bit number 2, which is that bit. If it's 0, it should be 1. If it's 1, it should be 0, and the rest should be the same. Let's check if this will result in what we want or not. 0 XOR 0 is 0 because both are similar. 0 XOR 1 is 1 because both are different. 1 XOR 0 is 1 because they are different. So far so good. 0 XOR 1 is 1 because they are different, and here you have 4 zeros and 4 ones, all are different, so you have 4 ones. Look, this is exactly what we started with. This is exactly what we started with. These 2 bits are exactly what we started with, but you know, bit number 2 here, the third bit, has been changed, has been toggled, basically from 0 to 1. Let's check now the, you know, the output registers. If you have, you know, 2 variables like this, 54 hexadecimal XOR'd with 78 hexadecimal. Let's do the, you know, the XORing bit by bit, bitwise, and see the result, you know, on the flag. So 0 XOR 0 is 0 because they are similar. 0 XOR 0 0 because they are similar. 0 XOR 1 is 1 because they are different. 0 XOR 1 is 1 because they are different. 1 XOR 1 is 0 because they are similar. 0 XOR 1 is 1 because they are different. 1 XOR 1 is 0 because they are similar. And 0 XOR 0 is 0 because they are similar. So the output here is not 0. So the 0 flag should be 0. The sign flag should be 0. The carry, without looking at the output, should be 0. And the parity here, since you have 3 ones, this is an odd number, so the parity is 0. Another example. Here we said that, you know, another application for the XOR, it can be used to clear the content of a register by XORing it with itself. So let's do that. So it assumes that H has a 45 hexadecimal. So let's XOR 45 with 45. 45 in binary is like this. You know, 1 XOR 1 is 0 because they are similar. 0 XOR 0 is 0 because they are similar, and so on. So the output here is 0. So the 0 flag, of course, will be 1. The carry flag, without looking at the output, automatically will be 0. The sign flag will be 0. And the parity flag will be 1 because, you know, here we have 0 number of ones, and 0 is considered an even number. So the parity is 1. Another logical operation is the compare operation. And it's very similar to subtraction, as we will see. So in the compare operation, we compare 2 numbers together if they are equal or one of them is, you know, is greater than the other. And this instruction doesn't affect the destination or the source. So the output will only affect, you know, the flags, but not the destination or the source. So, you know, OR affects the destination. And affects the destination. XOR affects the destination, but the compare here, CMB, doesn't affect the destination. It only affects the flags based on the comparison between the source and the destination, whether they are equal or one of them is greater than the other. The destination operand can be a register or a memory. The source operand can be a register, memory, or image, just like the AND, OR, and XOR. And here is, you know, what's gonna happen to the, you know, to the carry flag and the 0 flag when you make a compare. If the destination is greater than the source, and the order is very important, then both will be zeros. If the destination equal to the source, the carry will be 0, but the 0 flag will be 1. That's why it's similar to subtraction, because if you subtract 2 equal values from each other, the carry flag, I'm sorry, this is the carry flag, will be 0 and the 0 flag will be 1. If the destination is less than the source, the carry flag will be 1. And this is again happens when you subtract big number from a small number. And when you do that, we need to borrow, one, so that we can make the subtraction operation, because we can't subtract a bigger number from a small number unless we have a borrow. And the borrow here is like the overflow, or the carry, the overflow carry in addition. Okay. So this is very important. These three, rules, we can say. Again, if the destination is greater than the source, you have both are zeros, the carry flag and the zero flag, both will be zeros. If they are equal, the carry flag is zero, but the zero flag will be one. If the destination is less than the source, you have a carry flag of one, zero flag of zero. Here is a very, interesting example, that basically have, find the highest or the maximum value of a series in a series of 5 bytes or 5 numbers. Okay. And in that case here, of course, the maximum value of the 96. And this will be our, lab 5. So stay tuned, guys, for the, for this lab. In this lab, we're going to explore or explain in details this, application in which we use the comparing instruction. Okay, guys, thank you very much, and see you in the next video. Bye-bye.